Thank you very much. So what I'd like to do today is to tell you a little bit about if you take Fano's prescription of you can't create coherence, you shouldn't destroy it, seriously.
Talk about a problem in electron molecule scattering today, how an electron hits an H3 plus ion, breaks it up into either 2 or 3 neutral fragments, the process of dissociative recombination.
When one starts talking about history, one realizes that it's fraught with potential dangers. Number one, fuzzy memory. And in talking with different people, I see that we all have fuzzy memories, and the fuzzy memories don't always agree with each other.
Okay, so I will be talking about forming ultra-cold molecules, but before that, I want to say that I don't have any anecdotes about squash or tennis. I'm more of a winter sport type of guy.
This is not the beginning of my talk, it's the last page of my talk, yeah. And I thought about a very brief review of our recent work. Yeah.
Well, thank you very much, and it's a great pleasure for me to speak. It's a particular honor for me to speak here today. Like Ruben, I never played squash or tennis with Alex because by the time when I came to ITAMP in 2001, Alex's fame as squash player was so great that I was intimidated to ever play with him.
It's indeed a pleasure to be here for Alex's birthday. I guess everyone has their own personal story of how they came to work with Alex. The first time I met Alex was in 1993 at the ITAMP meeting in Aarhus in Denmark. That was soon after I joined Gert Bill.
Okay, well, I'm very honored to be here. First, I'd like to say it's been a pleasure last a number of years to have a chance to work with Alex. I've learned a lot, and most I've learned quite often what I don't know.
You and the other organizers for inviting me over here. I think it's very important that we have these focused workshops on a regular basis. And
so, thank you, Pierre. To be honest, I actually came here to learn about optonano-mechanics to somehow find out where the whole field is going, and I was a little bit surprised to find myself now as the first speaker in the session called Previsions.
There is a potentially interesting difference between molecular clouds as they existed at the time of reionization and present-day molecular clouds. And there's a point of difference between them that I want to draw to your attention. I'm going to say a few things about some collisional calculations that we have been doing with an eye toward recombination, this primordial or cosmological recombination. With Jens.
And I really hope we get to Bose-Einstein condensation, but since I've been asked to go over again some of the laser cooling ideas that I really talked about last week, I'm going to do that.
So that's what I want to talk about, if I can ever find the pointer. This is the subject. It should be no surprise, of course, that light quanta behave.
This particular crowd, I'll spend a very brief amount of time on motivations and an overview, tell you some details of the experiment, how we start with a cryogenic molecular beam, why we've chosen the particular molecule strontium fluoride to work on, some early results where we demonstrated that we could use optical cycling and apply radiative forces to the molecules.
Thanks for all sticking around. I kind of expected the room to be half empty by now, but everyone seems to want to stay for the entire workshop.
Okay, I also want to start out by thanking the organizers for inviting me here. And I want to thank Hugo for giving a very good introduction to what I'm going to be talking about, which is trying to access correlated electron motion on attosecond timescales.
So the first part of the talk will just be kind of a review quickly of the things I talked about last time. So quantum electrodynamics is the study of the quantum fluctuations of the electron magnetic field.
So we'll see how much I can convey to you guys in the 3 lectures that I have here. But it's nice to be here. Thanks to Pierre for inviting me and for organizing this winter school, which hopefully you guys are learning something from.
Okay, so let me start by thanking the organizers for inviting me here. When I got the invitation, I was thinking, what should I talk about? But finally, I chosen that subject, which is not maybe the main subject of the workshop, but it deals with, let's say, not too big, so few to many body systems, dipolar forces, and also dynamics and excitations.
So I'm very happy to be here, and I must say that what I'm going to present is not exactly in the hardcore of the conference because there is no temperature effect. I apologize, Jason. Jason always complains when I don't introduce temperature in my stuff, but there is no temperature in here.
So actually, part of the reason it's a great pleasure to be back. As Marcus said, I was a student here from 65 to 70, but that's ancient history for most of you young people now. But
Yeah, so welcome back. So let's hope the service kind of sweet. So you can judge at the end. As they said, so all the 3 lectures would be on multi-atoms and lattices. So kind of a little bit complementary, for example, to what we heard from Gallagher in the morning.
let me first say thank you to Hussein and the organizers for the invitation to speak here. Pleasure to come to the desert in the middle of winter. The focus in my research group in Madison is on using Rydberg atoms for quantum information, for quantum gates, quantum computation, quantum communication.
Yeah, so good morning everybody and welcome to the second day of our winter school. And my name is Peter Schmelter. I'm from the University of Hamburg, back in Germany, and specifically from the University of Hamburg Center for Optical Quantum Technologies. And this is the building. It's a 2 years old building. It is called a center, not a normal institute.
All right, so I'd like to start out by thanking the organizers for putting this kind of wonderful and diverse program together and for invitation, of course. So I would like to actually discuss today, just as a first talk in this workshop, a little bit give you a feeling, for this new frontier, which involves basically the interface between quantum optics or MO physics in general and nanoscience. So, but
Okay. Well, thank you, Svetlana, Irina, and Christian for having me. A nice, intimate crowd as always here at ITAMP. So, I suppose we're starting with the simple from the bottom up, and this is certainly a bottom-up talk. I'll give the maybe the only experimental ion talk at the meeting.
All right. So also let me emphasize that this work is in very close collaboration with the experimental group. It's a just combination of theory and experiment. And therefore, I want to start by thanking my collaborators. There is a very nice and fantastic theory team of postdocs, graduate students, and Misha even, that he's here.
Superradiance since decades and especially Guasaroche is a very well-known effect. Nevertheless, I mean, until something like half of a year ago, if you Googled superradiance, then what you got was something like this. So here he is, right?
So I came to ITAMP in September 1993 after getting a PhD from University of Colorado Boulder. Spent 3 years here, and a few of the important things happened during that time. First, in 1994, Shor's algorithm came, then quantum computation got started. And then 1995, although everybody know that they got Bose-Einstein condensate.
So thanks everybody for staying until the very last talk. And hopefully I will try to be short, brief. So first of all, I would like to join everybody else who has thanked Hussein for putting up this very nice workshop. This picture here is from one of the workshops that I have organized, and so I know that there is a lot of work involved in it. So thanks again for putting up this together.
Well, clocks, right? So
in a grandfather's clock, right? So you basically count the number of oscillations. If you know the number of oscillations, you just multiply it by the period, and that way you know time.
Okay, so I also would like, first of all, to thank Hussein for putting together this wonderful meeting here and for inviting me and giving me the opportunity to talk about my work that I essentially started here at ITAMP, but then also continued afterwards. And also there's kind of some people here at ITAMP which I also continue to work with.
So here's the outline of my talk. We'll start with a quick introduction, and then I will describe the method that we used, some of initial calculations, and the calculation of charge transfer per section.
So thanks very much. Thank you for the invitation to come here. I'm really looking very much forward to this workshop to sort of learn more about what kind of interesting things can be done with one-dimensional systems. And so I'll present to you like a range of experiments that we've done in our lab in the past few years. And
hi, my name is Hannes, and first of all I would like to thank the organizers for giving me the opportunity to present our work that I've been doing in Innsbruck together with Peter Zöller, which was my PhD supervisor, and in collaboration with Thomas Ramos and Benoit Darmache. So what I'm going to talk about will be very much motivated by work that we have sort of seen already in earlier talks today, where atoms or atom-like systems are coupled to 1D photonic waveguides and nanostructures.
To be back home. Well, not officially home anymore, but still home in some sense. It's really a tremendous pleasure to be here today to share with you some of our recent work on time.
I'm indeed immensely grateful to organizers for organizing it, because I need staff to organize a meeting of this size and this breadth.
And all right, so I'm going to take right off where Christian left us. And first of all, of course, thank the organizers. I really enjoyed this conference a lot. I think it's a wonderful group of experts discussing, very interesting new developments.
Right. Thanks for saying. So I will, in my lecture, talk a little bit about the specific problem of quantum many-body physics, which are quantum impurity problems, information on polaroids. So where we look basically at single impurity in the bath. If you think about the last lecture, it's a very tiny subsystem in a bigger system, which we'll be looking at. And,
so, thank you very much for inviting me. Kedon, please. Yeah. No problem. Yeah, it's an honor to be invited to such a wonderful conference. So I'm going to tell you about molecules in superfluid helium, which might be a little bit exotic to many of you, but actually I would like to give you some general motivation and our kind of big picture first.
So from several talks, we have already heard about some very exciting new progresses in terms of cooling and controlling cold molecules, as well as their applications for quantum chemistry, precision measurement, and so on. Here, I would like to discuss some prospects from a many-body perspective.
Well, thank you very much. Thank you for still being here. And okay, I should get that one too. Yeah, I do theory. And Marcos, thanks a lot for inviting me and Hussein. It's really a fun workshop. Also, thanks to John from my side for the whiskey yesterday.
So, one of the advantages of going towards the end is you can kind of summarize stuff that everyone has been talking about, because everybody already talked about a lot of the stuff on my slides. So that's what I'm going to do to some extent, and then talk about some new results that my group has been working towards for the past few months.
Okay, so I hope everything works now. I decided today to talk about not Fermi-Howard stuff for a change. I hope you all appreciate that. And instead, I want to talk about quantum state tomography, and in particular, how to make it adaptive during the measurement process.
Great, okay. Our second talk of the session is theoreticiable from
University of Nevada, Reno, who will be telling us about magnetic tuning of electric dipolar interactions in an ultra-cold molecular gas.
All right, thank you, Eric. Thank you, organizers, for inviting me to this wonderful.
Okay, cool. Hi, everyone. Thank you very much for being here. So today I want to talk to you about some of the work that I've been doing on trying to find and explore the presence of a dipolar chiral spin liquid on a stretched Kagame lattice.
Thanks. My name is Peking Yang from ITAMP division. I'm working together with the team. Okay, today firstly I will talk about our previous research on long-range reductions for three-atomic systems. Then I will talk about our current research on construct condition.
So let's start again. So the next talk will be of Simeon Mistakidis, and he will be talking about dipolar BECs with rotation.
Yeah, thank you very much for the kind introduction, and let me again thank all the speakers for the very nice talks up to now.
So saying, and yeah, of course, thanks to all of you for coming, staying, and discussing, giving great talks. It's been a pleasure so far, and I will also try to contribute now to this series of great talks. And you also already saw some work I was involved in regarding dipole-coupled arrays by Susanne Yelin today.
So first of all, I would like to thank the organizers. It's been a real pleasure being here, listening to the exciting talks yesterday, this morning, talking to people, and also just being back. I will talk about Rydberg interactions beyond the binary limit in two.
So I'm Vasilis, probably by now you have known who I am. And today I'm going to talk to you about quantum Hall physics in the cavity. Things that we already saw in the morning by Jerome.
First of all, I want to thank all of you for being here, and you made this workshop so much fun for me. Yeah, my name is Jaren. I'm an ITAMP fellow, and I do actually different types of physics, and mostly in the atomic side of the things.
In this second lecture of my trio, we're going to start off with reviewing the homework problem, and then we're going to return to Szilard's engine, look at some other versions of it, and especially focus on quantum effects.
Thank you, Ronnie, and I'd like to thank the organizers for inviting me here. It's a real pleasure to be here. So I'm going to tell you about some both theoretical and experimental results that have been obtained in collaborations with colleagues in China.
Thank you for the great introduction, and I'm glad you didn't show any embarrassing photos from grad school here. Next time, I'll do that really busy separate.
So there's a quick outline. Hopefully it's going to be about nanophotonics and how they combine atoms, cold atoms, in nanophotonic structures. And I want to thank all the members of my group.
Yes, hello everybody, and thank you for the invitation. I'm very happy to be here. I will be talking about my PhD work that I did in a group of Immanuel Bloch in Munich. Currently, you can find me in Paris in a group of Jean Daliba. And so what I will be presenting today is a slightly different approach to rotating Bose-Einstein condensates.
I kept this talk title a little bit more general because I actually don't want to talk only about the Rydberg. I also want to talk about cavity QED as two different ways to induce strong photon-photon interaction, but as you will see, some of the results are actually fairly similar, even though the systems are very different.
I'm going to tell you about ongoing work in my group making, in particular today, topological materials out of light.
So it's really a pleasure to be here, and I want to tell you, and I know this is a talk for a mostly we can call atoms audience, so I'll do my best. I think most of you know more about what I'm going to talk than myself, so I'll do my best and we'll see. So I want to tell you about our recent experiments on magic angle graphene superlattices. Yeah?
Going back to some of the issues that came up, so so I want to sort of reflect on a bit on my experience versus view on doing quantum optics theory at ITAMP in the pre-98 era.
So ask questions as we go through the talk. I actually planned out a lot of different things, but we don't have to get through everything. This is like a school. You should determine the pace of how we go through things, and you should give feedback. And if things get too quick for you, then the best way to slow me down is just to ask questions.
Thank you very much, Eugene, for this introduction. Thank you for having me here and coming to the talk. So
I've been here at least twice in the past few years, and I seem to always be talking about the same thing, which are experiments in which we've been studying the light-induced generation of superconducting fluctuations above the thermodynamic transition temperature.
First, I would like to thank Chris and Nigel for putting together this nice workshop. So I realize John's talk and my talk are about photons. So I have also some like review of the works that has been done in the photonic systems.
Quantum optics Texas style. Here you see Roy with his hat bands. And in particular, he has a friend, David Lee, who you know got the prize for demonstrating superfluidity in helium-3. And so the quantum optics Texas style is very real. There is...
My name is Amri Salavinaini. I am going to speak about interacting photons and phonons in silicon structures. So I started at Stanford in September 2014.
For me, this is this workshop is an incredible pleasure because I feel like this is home. This is my community. Everyone here is interested in the same things that I'm interested in. And that's a very unusual thing in cavity QED and many-body cavity QED. We're kind of a niche group in the wider world of AMO and many-body physics.
So let me join everybody else and thank the organizers for putting together this very nice conference. So what I'm going to talk about is some work we are trying to do, sort of trying to exploit these coupling of light and matter for quantum information processing. So just to set the stage here, of course, we all know which kind of system we are talking about. We have this atom here.
So yeah, this talk is going to be about the schedule order in multimode cavity QED. It's work I did with Yulia and Eugene, who are here. Actually did most of it when I was still here a couple of years ago. We're off by a sign error that I never could figure out. 2 years later, Yulia found a different sign error, and everything worked again, and so we could post the paper.
All right. Well, I'd like first to thank the organizer for inviting me to this a really very exciting workshop. I've learned a lot. So here I'd like to talk about some of the basic theory and computational approach for field photon transport in one-dimensional geometries.
So, well, thank you very much, Marcus and so on, the organizers for inviting me, Kaden and Wendy, and for coming to this exciting workshop. And I'm going to come here tell you something slightly different in terms of what connects metaphase that would be useful for.
Yeah, so this work involved many people. In particular, our two postdocs, Watson and Alex, as well as Yao. It's also collaborative between groups, between Jens Koch, who did a lot of the theory on the first two projects, and the last part is a tight collaboration between John and I.
Thanks, Nassim, and everybody at ITAMP for organizing this. It takes a lot of work to organize an event like that. It's incredible. I've done it with many other people once a birthday, and it's just crazy. But it needs to happen, and so good people sometimes make it happen. You should all be grateful.
Thank you, Anders. Like Mohammed, I also started my PhD by working a little bit with Anders, so I guess there's some correlations here. So thank you very much to the organizers for the invitation, and thanks to you for being here. In this horrible weather and the last day of the conference.
All right. So I thank you very much. I'm glad for the opportunity to be here and tell you about the work that I did during my PhD in Misha Lukin's group at Harvard in collaboration with Vladan Vuletic on creating kind of nanoscale quantum systems with single atoms. So.
People created several collaborators involved in this project here. So Fabian and Richard, who are no longer at Harvard, but started many of the important work in Tushar and Mario's continuing, and many ideas go back to the work started by Dimo when he was still at Harvard.
As a disclaimer, a lot of the work I'll be talking about is not much more than a week old, so this is the first time I'm talking about it, so it won't be as polished, but also feel free to interrupt me if
if you have questions or if something isn't quite clear. So I will be talking about artificial gauge fields in the quantum gas microscope.
So thank you very much for this kind invitation. I'm really happy to be here. This is a place where all these wonderful experiments happen that bring the world of quantum optics, quantum information forward. It's really great. So I'm spending here 3 days or so. It's the first day. I'm already totally exhausted, basically.